We know that there are three tests of similarity. SSS test, when all three corresponding sides are proportional. Second is SAS test, when two sides of two triangle are proportional and the angle between that two sides in both the triangle is congruent to each other. And the third is AAA test, that is angle test. Now we have to prove this angle test, that when three angles of triangle are congruent, here I'll assume angle A congruent to angle P, angle R congruent to angle C, and angle Q is congruent to angle B, which is given. It means three corresponding pairs of angles of two triangles are congruent, then both the triangles are similar. So you cannot write directly by AAA test of similarity, because we have to prove the same test only. So how to prove it? We will prove by SSS test of similarity. It means we have to prove that if angles are congruent, the sides are proportional. If we can prove that, then the triangles are similar by a SSS test of similarity. So how to prove it? This is important. Now for that we have two triangles, triangle ABC and triangle PQR. What you have to do? As angle A is congruent to angle P, now you have to take one more point on AB such that it is equal to PQ. So PQ is this much. I will take one point here, I'll name it as D, point D. Here AD is equal to PQ. Now PR, same PR here, and I will name it as point E. So PR equal to AE, and then simply you have to join DE. Now where are we doing this thing? In the bigger triangle. Whoever is the bigger triangle, we have to draw congruent triangle to the smaller triangle. Are you getting? Congruent triangle. Now you can prove that these two triangles are congruent. How they are congruent? One side correspond to second side, one angle is correspond to second angle, and this second side is correspond to this second side. So both triangle, this both smaller and this smaller triangle are congruent by SAS test of congruency, that we have proved. Triangle ADE is congruent to triangle PQR. By which test? SAS test. First of all, you should understand this much. As we know, the triangles are congruent, the corresponding angles are also congruent. That means angle Q is congruent to angle D, angle R is congruent to angle E. Am I right or not? Okay, now forget this triangle. Now we will consider in triangle ABC and triangle ADE. In these two triangles, angle D is congruent to angle B, transitivity. D is congruent to Q, Q is congruent to B, which is given. This you have proved by congruency. So D is congruent to B, right? As these two angles are congruent, angle D is congruent to angle B by transitivity, but they form the pair of corresponding angle. What they form the pair of? Corresponding angle. As they are the pair of corresponding angles, these two sides, these two segments are parallel to each other, because when corresponding angles are congruent, lines are parallel, and this is called corresponding angle test. So we have proved DE is parallel to BC by corresponding angle test. So now both the angles are congruent and lines are parallel. Now we know that in a triangle, when two parts are parallel, these two segments are parallel, that my BPT. Now by BPT, in triangle ABC, by BPT, AD upon DB equal to AE upon EC, right? AD upon DB and AE upon EC. But actually what we have to prove? Actually we have to prove the sides AD upon AB and AE upon AC, AD upon AB, AE upon AC, the sides of triangle, smaller and bigger, smaller and bigger. So now how we can prove that? Okay, now AD upon DB we have, right? First of all, what we will do? We will do invertendo. This is by BPT, I have already written, then too I am writing by BPT. Now by invertendo, so BD upon AD equal to EC upon AE by invertendo. Now tactfully, what you will do? Componendo. You know componendo means numerator plus denominator upon denominator on both the side. So numerator plus denominator upon denominator. Same on the other side also, numerator plus denominator upon denominator by componendo. Nendo. Now BD plus AD, BD plus AD, we got AB, we got the side of bigger triangle, that's what we need. Upon AD is already there, that is the side of smaller triangle. So yes, we got what we need, the bigger triangle side and smaller triangle side by componendo. Same here, EC, EC is this, EC plus AE, AE is this. So EC plus AE is AC, right? AC. So AC upon AE. Correct or not? Right or not? Right? Reason. If they ask, then we have to write A dash D dash B and A dash E dash C. Now what we will do? What we need to prove these two triangle, means triangle ABC should be similar to PQR. ABC should be similar to PQR. So AB upon AD. Now you know AD is congruent to PQ. AD is congruent to PQ. So instead of AD you can write PQ. PQ. Now AC will remain AC because that we need AC upon AC is equal to PR. PR. So we got AB upon PQ, AB upon PQ and AC upon PR. So we got two sides. Right now, a ratio of two sides are equal of these two triangles. So only two sides are proved to be equal, are proportional. Now similarly, we can draw the triangle here. Similarly, if we can plot one more part here, so we can prove AB upon BC. We don't have to do that, we don't have to show that, we have to just write similarly. Similarly, AB upon PQ can be shown equal to, AB upon PQ can be shown equal to BC upon QR. Mark it 2. Now from 1 and 2, see, as AB upon PQ is same, so by transitivity AB upon PQ equal to AC upon PR equal to BC upon QR. As you know, the corresponding sides of both triangle are proportional. Therefore, triangle ABC is similar to triangle PQR. By which test? SSS test of similarity, and hence proved. Then when angles are congruent, corresponding angles of both triangle are congruent, the triangles are similar, that is AA test is proved. This is just understanding what we did. What we did, understanding. Actual theorem with actual method we will do now. Hope you understood this understanding. Now actual theorem, AAA test. that is given in the page number 17, but it is not given completely in your textbook. Okay, so now statement: when three corresponding angles of two triangles are congruent, then two triangles are said to be similar to each other. That means angle A is congruent to angle P, angle B is congruent to angle Q, and angle C is congruent to angle R. So if these angles are congruent, then triangles are similar. We have to prove triangle ABC similar to triangle PQR. Now, how to prove it? So for that, first we have to construct something, construction, as we have done in understanding also. And what will be in construction? PQ should be equal to AD and PR should be equal to AE here. So take point D and take point E on AC, and first was on AB. So we'll write, first of all, ABC. Which triangle is bigger? ABC is bigger. So let triangle ABC be bigger. Triangle, then triangle PQR. Take points M and N. Instead of taking D and E, we will take M and N. M we will take here and we will take here. On side AB and AC, such that MN, sorry, not MN, AM. So let me take first, otherwise we will get confused. Scale, okay. Now PQ is coming, so approx. It is not compulsory that it has to be accurate. No, it is coming here. So now you have to join them. So definitely this will be M and this will be N. So AM equal to PQ and AN equal to PR, and draw seg MN. So these two triangles are congruent by which test? SAS test. But we have to prove that. Now proof. This was construction. Now we'll start with proof. In triangle AMN and triangle PQR, which test? SAS. So first we'll write side, then angle, and then side. So segment AM is congruent to segment PQ, and reason, construction, angle A is congruent to angle P, which is given. Segment AN is congruent to segment PR, which is construction. Therefore, triangle AMN is congruent to triangle PQR, and SAS test of congruency. As triangles are congruent, their corresponding angles are equal, right? Because we have to prove MN is parallel to BC. For that, corresponding angle should be equal. So angle M congruent to angle Q. Therefore angle M is congruent to, okay, I'll write in the next line. Therefore angle M congruent to angle Q. Reason, CACT, we will mark it as 1, but we know angle Q is already congruent to angle B, which is given. It is given B is congruent to Q. Therefore angle, this is mark it as 2. Therefore angle M is congruent to angle B, M is congruent to angle B from 1 and 2, or you can write transitivity. So, but what they form, M and B, they form the pair of corresponding angle, but angle M and angle B forms a pair of corresponding angles. Therefore, segment MN corresponding angle, therefore segment MN is parallel to side BC. And the reason, corresponding angle test. Corresponding angle test. Okay, now we will continue on this page. As we know, we have proved that these two sides are parallel. So now, in triangle ABC, first of all we'll mark this as 3, this parallel. Now in triangle ABC, seg MN is parallel to seg BC from 3. Therefore AM upon MB equal to AN upon NC. And the reason, BPT, basic proportionality. Theorem. Correct. Now what we will do, invertendo. So MB upon AM equal to NC upon AN by invertendo. Now after invertendo, what we have to do, componendo, numerator plus denominator upon denominator. So MB plus AM upon AM equal to AN plus NC upon AN by componendo. Now when you add MB and AM, we will get AB upon AM will remain AM, and AN plus NC will become AC upon AN. Reason, A dash M dash B and A dash N dash C. Right? Now, do we need AM? No. AM no. We need PQ. So AM is equal to PQ. So AB upon PQ equal to AC. Now AC upon AN. AN is equal to PR. So PR. Reason, AM equal to PQ and AN equal to PR in construction. Right? So we'll write, since now say this two equal sides, right? Now AB, now we proved AB upon PQ and AC upon PR. So two sides are proportional, corresponding sides are proportional. When two corresponding sides are proportional, now similarly we can prove third side also. Similarly we can prove AB upon PQ equal to third side is BC upon QR. Now we will mark this part as fourth and this one as fifth. Therefore AB upon PQ equal to BC upon QR equal to AC upon PR. Reason will be from 4 and 5. As sides are proportional, corresponding sides are proportional, triangles are similar by SSS test of similarity, and therefore triangle ABC is similar to triangle PQR by SSS test of similarity. Hence, proved what we need to prove. Proved that ABC is similar to PQR. So it means whenever the three corresponding angles of two triangles are congruent, triangles are similar by AAA test of similarity. Hope you understood this theorem.